Imagine you had knowledge of everything, how stuff interacts, how things should happen, etc., everything. If you're given a scenario, shouldn't you be able to calculate exactly how everything should end up? Essentially, couldn't you predict the future? It's only a matter of time before what you calculate will happens. Well, if you're a good shot. This reflects a scientific concept called total determinism, in which people view that the future is already fixed based off the initial conditions of the present. But can we know everything? Is it truly possible to predict the future? After the arrival of Newtonian physics, it looked like we could just calculate everything and thus predict the future. However, we soon started to find stuff like quantum spin, which we couldn't calculate, so we had to rethink our answer. But what about weather? Can we predict the weather? Scientist Edward Lorenz one day was working on just that problem, trying to figure out how to predict the weather. He managed to create 3 differential equations, which contained 3 weather variables. Each set of variables would represent a state of weather, and as the variables go through the equations, the variables change over time, and thus the weather changes. We can demonstrate that on this 3D graph, as the variables representing a weather state change over time. Here might be peaceful weather, while here might be a thunderstorm. Lorenz conducted trials in which he took states of weather and calculated their future. He got the same results repeatedly until one time he got completely different future weather states. Why? It was because while his original numbers had 6 decimal places, he accidentally used 3. Looking deeper, we have a graph with weather states that started very close to each other, but they too lead to completely different weather states over time. Do you see the trend? The smallest difference of a coordinate would cause a drastic change. We have to know the exact coordinate in order to calculate the future weather. But since knowing the exact weather is basically impossible, he concluded that it was impossible to predict the weather with accuracy because we could never perfectly know the conditions of it. This is what chaos is, when the exact present determines the exact future, but the approximate present does not determine the approximate future. As we continue to analyze Lorenz's equations by tracking the path of each weather combination, we see that they are attracted to what we call attractors. These are called the Lorentz attractors, and they are one of the most famous discoveries in chaos theory. As we researched more into chaos, scientists began to find patterns, repetition, organization, and even types of feedback loops. Here, chaos theory is born, taking what seems to be absolute madness, chaos, and finding the underlying structures in it. So can we predict the future? Yes, but it's difficult. But the underlying structures we find in chaos theory give us the keys to do so. Chaos theory has been applied to numerous sciences, such as cryptography, physics, biology, psychology, and many other science fields. One of my favorite ideas that has come out of chaos theory is the idea called the butterfly effect, in which small actions can lead to unforeseen consequences. The small differences our actions make can lead to huge changes in the future. Things from you watching this video to me producing it could lead to exponential changes that none of us could have foreseen occurring. And that's where I see the beauty of chaos theory. It's not just a math theory, it's a testament to how complex and interconnected life is.